Hi everyone, so welcome to my lesson on the periodic table chemistry topic. I'm going to go back to basics a bit here, but I'm going to give you some advice. When you walk into that chemistry exam, the paper one, you always get given a periodic table, and quite a lot of my students don't think that they can write anything on it, or that they'll be disqualified or something. But it's yours to use. It's almost like use it as like an extra bit of help in the exam. So I always say, as soon as you get in there, before you even start the questions, do like a brain dump, because what happens is you panic a little bit and you can tend to forget or muddle things up in the exam. So you just dump all that information that you've learned, put all that effort in learning onto your periodic table, and then when a question comes up, which it will, about one of the elements or something, then you've got it all there written down already. So when you go into the exam, you're going to brain dump and you're going to just make notes on your periodic table. So your periodic table might look a bit like this one that I've got here. So the first thing that you need to know about the periodic table is what do all the things mean. So these at the top are groups. So you're going to write here on the top. These are the number. These tell you the number of electrons in the outer shell. Okay, so this is what these numbers are. So 1, 2, 3, 4, 5, 6, these ones in the middle, we don't need to know those ones, but these groups, group 1 all the way to group 0 over here, this tells you how many electrons they have in the outer shell. Okay, so that's the group. The periods, which are the rows over here, so at the side you're going to write the number of shells. So the periods tell you how many shells the atom has. So starting from the very top row, which has hydrogen in it and helium, they have one shell. So then it goes down from there. So starting with lithium and going across, that's 2 shells, 3 shells, 4 shells, and so on. Okay, and if you don't know what I mean by shell, I'll talk about that in a little while. Okay, so let's talk about each tile on here then. So there are some numbers. The larger number is always the mass number, and you'll be given a key that looks like this, and it does tell you that. So remember, the mass is everything in the nucleus together. So everything in the nucleus is protons and neutrons added up together. And then the atomic number will be the number of protons, but it will also be the number of electrons, or electrons. So remember that. You might be asked to work out how many neutrons or something like that in a atom of something. So the numbers, you'll be able to see them a little bit clearer, a bit smaller on here. So working out, let's take for example boron. So we've got 11 as our mass number, and we've got 5 as our atomic number, or number of protons. So if the question was how many neutrons does boron have, you take the mass and you need to subtract how many protons there are, because the mass is both protons and neutrons together. So if you take how many protons there are, then that just leaves you with neutrons. So the mass is 11, and we're going to take away 5, so that gives us an answer of 6 neutrons. For example, that's a nice easy one. If you didn't know how to do that, then practice that, but you do get the hang of it pretty quickly. Okay, right, so let's have a look at sort of breaking down into each atom then, and the electronic configuration. But before we do that, quickly, we're going to look at some trends. So you might also be asked about the trends in the periodic table, and the two sides of the periodic table are non-metals, and the non-metals and the metals. The non-metals are on the right-hand side, and the metals are on the left-hand side. And there's a line that divides the two sides of the periodic table. So you're going to draw in your line that looks a bit like a sort of set of steps, and you're just going to continue your way down. So you start Start from boron and you continue all the way down. The steps go down till you get to the bottom. And sometimes you might see it slightly differently. It's because these either side of the line are kind of halfway between metals and non-metals. So your smaller side is your non-metals and the bigger side is your metals. And that's the basic sort of split between the two sides. Okay, so trends. If you look at group 1, which is the first group here, you are going to draw with your brain dump an arrow pointing downwards. Why have you done that? Well, it's because as these elements go down the group, they become more reactive. Okay, so the other thing is to come over to group 7 and you are going to draw an arrow going upwards next to group 7. It's because you can be asked, what's the trend? Well, as you go up the group, it becomes more reactive. So in other words, if you go down the group, it becomes less reactive. It's the opposite to group 1. Okay, and 1 and 7 add up to 8, and that's important in a minute, or when we talk about bonding, that'll be important. Right, so we're going to have a look at electronic configuration. We're going to take a few examples and we're going to just draw them out because that could also be asked in the exam. Let's go for some in different groups. Let's go for lithium. Let's do 2. So let's go for lithium group 1 and fluorine in group 7. Okay, so what's the atomic number? The atomic number for lithium is 3 and for fluorine it is 9. And if we go for the configuration, okay, so what does that mean? So in the shells, we talked about the shells, that's the sort of layers of electrons surrounding the nucleus, and we draw it as circles. That's how many electrons are on each one. So the closest shell to the nucleus can only take 2 electrons maximum. But then after that, we can have a maximum of 8 on each shell. So it would go like, if they were filled up to the max, it would go like that and carry on like that. Okay? You're not going to fill it up to the max because we've only got 3 in total, so we've used 2, which means that we've only got 1 left on that outer shell. And we said, didn't we, at the start, that the group is the number of electrons on the outer shell, and lithium is in group 1, so we should have a number 1 here. So it would be the same for sodium and potassium and so on. They would all have a number 1 as that last number there. Okay, let's look at fluorine's electronic configuration. So it will have 2, because that's its maximum on its inner shell. And then we've got to make 9. We've used 2, so that means we're going to have 7 here. We still haven't maxed out, we've still got a spare space there. So, fluorine, if you look, is in group 7, so that makes sense because it should have 7 as per the periodic table. Okay, so the diagram, so we would have lithium, we're going to have, how many shells do we need to draw? Well, to work that out, we're going to look at the period. It's in the second period down, so it's going to have 2 shells like that, and we always draw our electrons as neat dots or crosses. I always go for crosses. So 2 on the inner, and then I'll do this one over here, 1 on the outer like that. And finally, fluorine, a little F for the nucleus, then we've got 2 shells again. Okay, so 2 shells, and then we've got 2 on the inner, and we've got to do 7 this time. So I'll do them in pairs, it's easy to count. So 2, 4, 6, and then 1 more makes 7. And what that means is it helps us when we do bonding later, because fluorine is going to want to fill that gap, which makes it want to react with things. But we'll talk about that in another video. Okay. If you found that helpful, please subscribe to my channel on YouTube. Thanks ever so much. Thanks.